So here we're asked to find the inverse function for the given function f of x, use composition to verify that they are inverses, and then graph both the function and its inverse. So to start us off here, we're going to find the inverse. And to do that, I'm going to go ahead and plug in y for f of x, and then I'm going to do the inverses to solve for x. So I'm going to add 2 to both sides. So y plus 2 equals 2/5 x. Then I'm going to divide both sides by 2/5 or multiply by 5/2. I'm actually going to distribute this into both to get 5y plus 10/2 equals x. Now I'm going to switch out x and y to get y equals 5x plus 10/2. And then my inverse is going to be f negative 1 of x equals f of x plus 5x plus 10/2. So next we're going to make sure that we are correct by using composition, by plugging in these different functions into each other. So for the first one, I'm going to go ahead and take f of x, or the original function here, but I'm going to plug in the inverse for everywhere I see x. So instead of saying f of x, I'm going to say f of the inverse function. And then I'm going to write the original function, but every time I see the letter x, instead of plugging in x, I'm plugging in the inverse function. So 2/5 times 5x plus 10/2. And then I'm finishing out, again, that was just the x value here, so minus 2. So then I'm going to multiply this through here. I'm going to distribute here to get 10x plus 20 over 10, which in this case ends up leaving us with, when we cancel out this 10 from each factor here, we get x plus 2 minus 2, and plus 2 minus 2 leaves us with just x, which is what we were hoping for. Now next, I'm going to do the same idea, but instead I'm going to take the inverse function, and everywhere I see x, I'm going to plug in the original function. So what that looks like here, let's go to the side here, f negative 1 of f of x, because instead of x, I'm plugging in the function. And so I start by saying 5 times x. I see an x, so I'm going to plug in 2/5 x minus 2 plus 10/2. So now I'm going to solve this. So I'm going to distribute this into here. That gives me 2x minus 10 plus 10/2. Minus 10 plus 10 cancels out, leaves me with 2x/2. 2's cancel out and leave me with just x, which is what I was hoping for. Now to graph, I'm going to go ahead and clear this up a little bit, and I'll rewrite the inverse function here. So we have f negative 1 of x is 5x plus 10/2. So now we're asked to graph each of these. So we already confirmed it, we verified. So first I'm going to start with the original function because it gives me, I'm going to use that in purple. So it gives me a y-intercept here of -2, and then a slope of 2/5. So every time we go up 2 and over 5, so our graph should look like this. Now remember, with an inverse function, the points are all just flipped over this y equals x. So instead of actually like plugging in some points, which we could do, we could make a t-chart, x values, y values, and plug in points. We can also just flip it over this line here and have a couple points that make it nice and easy, like this one here, and it looks like this one here. So our inverse function should look like that.